This is Higher 2 Chapter 2. In this chapter we're going to be covering surds, rationalizing the denominator, number problems and reasoning. Now before you can cover surds you need to understand what a square number is. A square number is worked out by multiplying a number by itself. So 1 times 1 is 1, 8 times 8 is 64, 12 times 12 is 144. Each of these numbers are square numbers, and you have to be familiar with all of these numbers for us to be able to deal with surds. Now surds can be simplified. For example, if you had the square root of 200, it can be simplified, which we're going to cover next. But before that, you need to understand some rules when you're dealing with surds. Now, a surd is something that can't be simplified, like the square root of 6. It can't be worked out. The square root of 7, or the square root of 15. Each of them is a surd as they have a root over them and they cannot be worked out. Now if you were to add two surds, so if I was to do the square root of 2 plus the square root of 3, this cannot be worked out. But you can do the square root of 2 multiplied by the square root of 3. Now this can also be written as root 2 root 3. It means the same thing. So we can multiply the 2 and the 3. Whatever's inside the roots can be multiplied together. So 2 times 3 is 6. So we're going to have the square root of 6. Now this also works with division. So if I was to do root 2 divided by root 3, that's the same as 2 over 3 square root, and vice versa. Now to simplify a surd, now there's two methods. Now if you're more familiar with surds, we're going to cover that in the second method. Now the simpler method is this, to break down a number into its prime factors. So here we have 75 and we're going to put it in a grid. Now we know 5 is a prime number and it goes into 75. We can divide it by 5. We're going to be left with 15. Divided by 3. We get 5. Divided by 5. You get 1. Now this essentially means that the square root of 5 multiplied by the square root of 3 multiplied by the square root of 5 will give us root 75. So root 5, and root 3 equals to root 75. Now if I do root 5 times root 5, that gives me root 25. Then root 3. The square root of 25 is 5, and then you have root 3 left on the side. So when you multiply any surd by itself, or anything with a square root over it, by itself, the square roots essentially cancel out. So if you were to do root 10 multiplied by root 10, your solution would be 10. Because root 10 multiplied by root 10 is root 100, which is 10. Another method of working this out is, so this is method 1, and method 2 is to write root 75 and break it down into a square number and a non-square number. Now, the square number you can break 75 into is root 25. So you're going to break it up into root 25 and root 3 is remaining. The square root of 25 is 5 and then root 3 stays on the side. Root 208 can be simplified by putting it in a grid and dividing it by prime numbers as much as possible. So we're going to divide it by 2, we're going to get 104. Divided by 2 again, we're going to get 52. Divided by 2, 26. Divided by 2, and that's going to give us 13. Divide the 13 by 13, and we're going to get 1. Now all of these numbers in the first column are roots. So you have root 2, 4 of them, and then root 13. Now root 2 times root 2 is going to give us 2. So we're going to pair them up and we get 2 here. Pair up these two and we're going to get another 2. So times 2. Then root 13 is left on its own. So we're going to write times root 13. So 2 times 2 is 4. And then you just have root 13 next to it. And the next question, the square root of 300. Now this is a simpler question. Now here we can see the square number inside it is 100. So we can break up root 300 into root 100 and root 3. The square root of 100 is 10. And then you just write root 3 next to it. Now question 2 says express the following in the forms n root 3, p root 5, and q root 7. Now they've given you a hint on what one of the numbers is going to be when you break it up into a square number and a non-square number. So question A is going to be n root 3. So it means there's going to be a root 3 inside root 75. So if I pull out the root 3, we're going to have root 25 and then root 3 next to it. And that's going to give us 5 root 3. Next one has root 5. So we're going to break it up into root 5 and the next number is going to be root 9. So I always like to write the square number first. So root 9 and then root 5. We're going to get 3 root 5. The next question. This can be broken up into root 9 and root 7, which is simplified into 3 root 7. Exercise 2.3 is where you have to add various surds, but before you can do that you have to simplify them so they're in the same form. Otherwise you won't be able to collect them. So what you need to do is that you want to simplify each of them separately. So we're going to have 3 root 28. Now root 28 can be broken down into root 4 and root 7. So we're going to have 3 times root 4 and root 7. Square root of 4 is 2. So 3 times 2 root 7, which is going to give us 6 root 7. Now we have 2 root 63. That can be simplified into 2 root 9 and root 7, which is 2 times 3 root 7, which is 6 root 7. So the final one, 3 root 7, is already simplified and nothing can be done to it further. So now we're going to plug in the new simplified versions back where the originals were. So we're going to have 6 root 7. Now remember the signs have to be the same as well. So minus 6 root 7 plus 3 root 7. Now anything take away itself, it cancels out. So like 2 take away 2 is 0. So 6 root 7 minus 6 root 7 is 0 as well. So these two cancel out. And your final solution is going to be 3 root 7. Exercise 2.4. Now here we're going to be squaring everything inside the brackets. Now the square is applied to everything. So here we have a half is applied to the numerator and the denominator. So the square of 1 is just 1. The square of 2 is 4 multiplied by, now the square of any root, remember any root multiplied by itself, the root cancels out. So root 3 times root 3 is going to give us 3. When you multiply these two, we're going to get 3 over 4 as 3 as a fraction is 3 over 1. So 1 times 3 is 3 and 4 times 1 is 4. Exercise 2.5. And in this exercise we're going to be expanding brackets which have surds. Now the first question here is asking us to expand this bracket with root 2. Now root 2 times 3 is going to give us 3 root 2. then root 2 times root 2 is going to give us plus 2. Now here we're going to do 3 times 5 and 3 times root 2 minus root 2 times 5 and minus root 2 times root 2. Now 3 times 5 is going to give us 15. 3 times root 2 is going to give us plus 3 root 2. Minus root 2 times 5 is going to give us minus 5 root 2. And minus root 2 times root 2 is going to give us minus 2. Now when you get the like terms, 15 minus 2 is going to give us 13. 3 root 2 minus 5 root 2 is going to give us minus 2 root 2. Question number 4. The area of the square is 80 cubic. The area of the square is 80 square centimeters. Find the perimeter of the square. Give your answer as a surd in its simplest form. So, we have a square. The area inside is 80 square centimeters. Now we know the length and the width of a square is the same. So we can use the same letter to represent the length and the width. So we can write A over here, and we can write A over here. So A times A gives us 80. So we're going to write down A times A equals to 80. So A times A is A squared. That's going to equal to 80. Now the square root of A squared is going to give us A. So what we're going to do, we're going to square root one side and we square root the other side. Now the square and the square root cancel out. So we're going to get A equals to the root of 80. Now square root 80 can be simplified further, and that's going to give us root 16 and root 5. And the square root of 16 is 4, and then you have root 5 next to it. Now the question is asking us for the perimeter. Now perimeter of a square is going to be 4 times the length. So 4A would be the perimeter. So we're going to do 4 times 4 root 5, and that's going to give us 16 root 5 centimeters. This is exercise 2.6. Here we're going to be rationalizing the This is exercise 2.6. Here we are going to be rationalizing the denominators. Now, to rationalize the denominator, it means to get rid of the root from the denominator. Now, we have 4 over root 5. Now, we know the only way to get rid of the square root here is to multiply the root 5 by itself. So we're going to multiply it by root 5. So whatever you do to one side, you do it to the other side. You multiply the top by root 5. And we're going to get 4 root 5 over 5. Now here in the second question we have 2 root 5. So does that mean we times the denominator by 2 root 5? No. We still times it by just by the root. So we have 5 over 2 root 5. So you multiply the denominator by root 5 and you times the top by root 5. So we're going to get 5 root 5 over 2 times 5, and that's going to give us 5 root 5 over 10. Now in this case we have 5 and 10. Now these two integers are both multiples of 5, so we can divide them both by 5. So 5 becomes 1, 10 becomes 2. Now simplify the fraction and we get root 5 over 2. Question 7. Here we're going to multiply the denominator by root 7, and we multiply everything at the top by root 7 as well. So root 7 times root 7 is going to give us 7, and minus 35 times root 7 is minus 35 root 7 over 7. Now here everything can be divided by 7. Now as we have a minus sign, we have to divide everything individually by 7. Now 7 divided by 7 up here is 1. Then minus 35 divided by 7 is minus 5 root 7. Exercise 2.7. In this exercise, we're still going to be rationalizing, but a different type of denominator. In these denominators, we have a plus or a minus. Now, for us to rationalize these denominators, we need to multiply the denominator by itself, but with the opposite sign. So if we have 5 minus root 7 over 3 plus root 7. So we're going to be multiplying the whole denominator by 3 minus root 7. So you have to use the opposite sign for the roots to cancel out at the end. So when you expand it, you will not have any roots left over in the denominator. So you're going to multiply the numerator by the exact same. So you're going to multiply it by 3 minus root 7. And when you expand it, remember you're going to treat these as double brackets now. 5 times 3 is going to give me 15. 5 times minus 7, minus root 7 is minus 5 root 7. Minus root 7 times 3 is going to give us minus 3 root 7. Then minus 7, minus root 7 times minus root 7 is going to give me plus 7. Now 3 times 3 is 9. 3 times minus root 7 is minus 3 root 7. And then root 7 times 3 is going to give me plus 3 root 7. Root 7 times minus root 7 is minus 7. Now here, if you notice that everything inside the brackets for the denominator, so you have 3 plus root 7 and then you have 3 minus root 7, everything is the same except for the sign. So here you can also do difference of two squares, meaning that you're just going to get 3 squared minus root 7 squared. So 9 minus 7. Because if we look over here, minus 3 root 7 and plus 3 root 7, they cancel out. And if I collect the like terms, we're going to have 15 plus 7, which is 22, minus 8 root 7 over 2. Now here, everything is an even number, so we got 22, we got 8, we got 2. Now it means we can divide each of them by 2. So 22 divided by 2 is 11. Minus 8 divided by 2 is minus 4 over root 7. And 2 divided by 2 is 1. And you don't need to put anything over 1 as it doesn't change. Marie has 25 cards. Each card has a different symbol on it. Marie gives one card to Shelley and one card to Pauline. In how many different ways can Marie do this? Now here we're working out a number of possible combinations. And this whole exercise is covering combinations. Now, these 25 cards, they all have different symbols on them. So they're all unique. Meaning that no two cards are the same. So if we're going to work out different ways Marie can do this, all we have to do is select one card. Now how many cards can we select from? 25. So we're going to write down 25 here. Now how many cards are remaining for Pauline to select from? 24. So to work out the number of possible combinations, we have to do 25 multiplied by 24. And that's going to give us 600. So if you're looking at the same group, your number will decrease by 1. So in this case, 25 became 24. Now the next question, question 2. There are 14 boys and 12 girls in a class. Work out the total number of ways that one boy and one girl can be chosen from the class. Now here, these are two separate groups, boys and girls. As the groups are distinct, question 2. There are 14 boys and 12 girls in a class. Work out the total number of ways that one boy and one girl can be chosen from the class. Now, to work out the number of possible combinations, all we have to do is multiply the two options given to us, boys and the girls. So as there's 14 boys, we take 14 and we multiply it by 12. And that's going to give us 168. If they were to say 2 boys, it would be 14 times 13, as you would decrease 14 by 1. If they said 2 girls, we would do 12 times 11. Question 3. There are 17 men and 26 women in a choir. The choir is going to sing at a concert. One of the men and one of the women are going to be chosen to make a pair to sing the first song. Work out the number of different pairs that can be chosen. Now here, since we're looking at two distinct groups, men and women, what we're going to do is simply multiply them. So we're going to do 17 multiplied by 26. And that's going to give us 442. Now, even though they're said different pairs, as the two groups are distinct, we can't divide it by 2. Unlike the next question, where they say 2 of the men are going to be chosen to make a pair to sing the second song. Ben thinks the number of different pairs that can be chosen is 136. Mark thinks the number of different pairs that can be chosen is 272. Who is correct? Now, if we're looking at the same group, in this case it's men, so we've got 17. If we select another man, it has to be from 16 men. So we're going to do 17 times 16. But since we're looking at the same group, we have to divide it by 2. So we're going to do 17 times 16 divided by 2. And that's going to give us 136. Now, who's correct? Ben. Ben is correct, as he divided by 2. Umi has a 5-digit password for her tablet. Each digit can have a value between 0 and 9 inclusive. How many choices are possible for each digit of the code? Now, 0 to 9 inclusive, that is going to be 10 digits, as we are including the 0 and the 9. So there are 10 possible choices for each digit of the code. Now, what is the total number of 5-digit passwords that Umi can create? Now, if there's 10 possible choices you can have for each digit, it means you're going to do 10 times 10 times 10 times 10 times 10. That means we're going to have 5 zeros. So we're going to have 1, 2, 3, 4, 5. 100,000 possible passwords. Umi would like to choose an odd number. The code can start with a 0. Determine how many different ways are possible now. Now, here in this question, they're putting a limitation on the number. They're saying it's an odd number. So if it's an odd number, how do we know if it's odd or even? By looking at the number it ends in. So if it ends in an odd number, it's an odd number. So from 0 to 9, how many numbers are odd? 5 numbers. So we have 5 possible choices for the last digit. Now, the code can start with a 0. Now, usually numbers don't start with a 0, but here they're putting 0 as a possibility. So it means there's no limitation for the starting number. So it's still 10 possible choices. So we're going to put 10 in the first box, and there's no limitation on the other 3 numbers. So 10 in the others as well. And now we just multiply each of them together. And that's going to give us 50,000. This is question 6a, part 2. Now, how many codes can Hamza generate using 3 numbers followed by 2 letters? Now, there's no limitations put on this, so 3 numbers, that can be 10 times 10 times 10. Now, 2 letters from the alphabet. Now, there are 26 letters, so we're going to do times 26 times 26. And when we pop this in the calculator, we're going to get 676,000. Now we're going to do its counterpart question in part B. Now Hamza's friend advises him not to repeat a digit or a letter. So how would you do part 2 for question B? Now remember, we have 3 numbers and 2 letters. Now the first number that we're going to be selecting is going to be from 10 possible digits. Then we have 9, and then we have 8, as we are not repeating any of the digits. So if you select a 1, we have 9 numbers left to select from. And if I select a 2, there are 8 numbers left to select from. Then we have 26 for the next one. Now, as we selected one letter from the alphabet, now there are 25 possible options left. So we're going to write 25 for the last box. Now we multiply all of these together, and that's going to give us 468,000.